cut off on number 17 on the last video, so I'm going to go ahead and do it again. It's one of the most missed problems on the test, just like its counterpart back on page 2, number 10, which is the same kind of problem. If you look at it, it has two terms in the denominator, and we get rid of the radicals by multiplying by the conjugate. So same kind of problem, but now we're just trying to eliminate the i's. And I see this camera does not like me flipping the pages, so I'm going to try to keep her steady here. So the problem is i's and radicals are never allowed to be left in a denominator. So anytime we have an I in the denominator, in order to get rid of it, we need to multiply both the numerator and the denominator by its conjugate. So the conjugate of 3 minus 2i is 3 plus 2i. Remember, for the conjugate, all we do is change the sign. Not only is this on your next test, this is also on your final exam. So this is a good one to make sure you know how to do. And whatever we do to the denominator, excuse me, we also must do to the numerator, exact same thing, because remember, this is really 1. Anything divided by itself is 1. So multiplying that fraction by 1 is not going to change its value. It's going to change its looks, but that's it. Okay, so as we discussed in the last video, this numerator is a distribution problem. And the denominator, just like the radical number 10 on the other page, because these are conjugates, remember we only have to do F and L. So in the numerator, we get 18i plus 12i squared. In the denominator, when we do F and L, we get 9 minus 4i squared. And again, we only have to do F and L because the middle terms will always cancel on conjugates. Negative 6i plus 6i, they go away, the O and I. So that's why we can just do the F and L. But the first thing we learned when we learned imaginary numbers, or second thing we learned, is that I squared is really -1. So anywhere you see an I squared, this is just I, so don't do it. Anywhere you see an I squared, replace it with -1. So that leaves us with 18i positive 12 times, remember this is a times problem, times -1 is -12. 9, and this is -4 times -1. A negative times a negative is positive, so it's going to be 9 plus 4. So I think this is about where we were at on the last video. So as I pointed out on the last video, the directions ask for this in A plus BI form. That means two things. The real part has to be listed first. And the second thing it means is that our fractions need to be split up into two parts. So those are the two things we have left to do in this problem. So does everybody recognize that this is in the incorrect order? It's not A plus BI form. The I has to be second. So when we turn it around, we have to be super careful with the signs. Negative goes with the 12, so -12 is first. 18 has no sign in front, so that means it's plus 18i. In the denominator, 9 plus 4, 13. So then, as I said, in order to be in standard form, that means the real part has to be first, imaginary part second. So we can't leave it in a fraction. We have to break this into two parts. So our final answer, and to get credit on the test, you do have to have it in standard form. -12/13 plus 18/13 I. and now it is in A plus BI form. So hopefully you recognize the next problem as being a FOIL. 2 terms times 2 terms, no sign in between, so that means multiplication. So can we just do F and L on this one? We can't, right? They are not conjugates, so we have to do FOIL. We have to do all 4 steps. So these F and L, because they were conjugates, 1 minus, 1 plus, otherwise identical. So from F we get 9, outer, negative 12i, inner, negative 6i, and last, positive 8i squared. And I can tell you that's where 99% of the mistakes are made on that step. Students forget the I squared or they miss the sign. So positive 8 and then add the exponent, so I squared. But immediately you should be going, oh, wait a minute. We know I squared is negative 1. We wrote it about 4 times on our 6.8 notes. So we need to replace that with negative 1. And now our new problem is going to be 9 minus 12i minus 6i. Positive 8 times negative 1 is negative 8. Now we're ready to write our final answer. And remember, it does have to be in standard form. So 9 minus 8 is 1. Negative 12i and negative 6i, negative 18i. So notice it is in A plus BI form. Okay, our last section we studied in our notes were solving radical equations. So I put 2 pretty easy ones on your test and 2 that were a little bit more difficult. So these are the 2 easy ones, and we'll save the 2 harder ones for the next video. So step number 1, and I would write that big here to remind yourself, is isolate, keep on the screen, Norris, right? Isolate the radical. That means get the radical all by itself, preferably on the left-hand side. So does everyone agree? Radical's isolated, nothing else is over there but the radical. So step 2 was raise both sides to the power of the radical. So power, let's say, of the index. That sounds better. So I look at my index. It's a 2. Because remember, if it's not there, we can imagine that it's a 2. It's an imaginary one or an assumed one. So then we raise both sides to the second power. And we learned in 6.8, those 2 undo each other. That's the whole reason we do it. And we get x plus 2 equals 64. Simple little algebra problem to solve here, and we get x equals 62. Done? No, we are not. Remember, every even index must be checked. Reason? Even indices pick up extraneous solutions. So we have to check and make sure that solution is valid before we put it in solution sets. So let's just write check here. So we know that's part of the problem. And we're going to put 62 right up there where x is. We want to know, is 62 plus 2, does that equal 8? So you tell me, is the square root of 64 equal to 8? Absolutely. So then I take my answer and put it in solution sets to show the reader Not only was it a potential solution, it checked, so now it is therefore the valid solution. So 62. And we have time to do one more. And like I said, I'm going to cut this video a little short because I know we can't get the last two on the same video. So I'll just put them together at the end. So this problem is almost identical to 19. Really, the only difference is we have a cube root instead of a square root. So cube roots require that we raise both sides to the power of 3. Notice the radical's already isolated, so nothing's outside of it or on the same side as the radical. So step 1, get over here, step 1 has been satisfied. So step 2, raise both sides to the power of the index. So power of 3, power of 3. And just like on the last problem, the cube root and cube undo each other because they're opposite operations. So what's under the radical just pops out. And then on the right-hand side, we do 3 times 3 times 3, which is 27. And then we just have a simple little 2-step algebra equation to solve. And the cool news on this, it's an odd index, doesn't need to be checked. If I was taking a test, I would check it just to make sure my work is correct. But odd indices don't pick up extraneous solutions. So if you did happen to run out of time on the test and didn't have time to check it, you don't have to worry about extraneous solutions. So to solve this algebra equation, we need to get x alone. So I did the opposite and added 4 to both sides. So 2x equals 31. Divide by 2, divide by 2. So x equals 31 halves. And of course, you could write 15 and a half, 15.5, but there's really no need. So save time, just give a simplified fraction, which is what we did. Okay, we'll stop this video for now, and if you want to watch the last two, that will be on the next video. And the last two are definitely high miss problems on the test, so you definitely want to look over that video.